Okay, so let's begin making our genetic algorithm. So the first thing we're going to need is we're going to need a solution to store in a collection of solutions. So pretty much I'm going to make a struct. And the struct is going to have variables. So it's going to have a rank. It's going to have x, y, and z. Then we're going to have a fitness function. So I'm going to define a fitness function like this. Now, this fitness function is going to check the fitness of a function that I'm going to just define inside of here. So I'm going to define answer to, what is the answer of 6 times x plus negative y plus z to the power of 200. And I want to know how close this is to 25. So I'm going to subtract 25 from here. Okay, so we're checking how close is this quote-unquote function to 25. And to check how close it is, I'm going to say the rank. So how good is this function? We're basically assigning a greater value to rank based on whether or not this function is closer to 0 or not. So we're going to say ans is equal to 0. If it is, we're going to assign rank the value of 9,000. Otherwise, we're going to assign rank the value of the absolute value of 1 divided by answer. Okay, so to explain what's happening here, pretty much what I'm doing is to rank, we're assigning is answer equal to 0. So is this exactly 0? So the variables x, y, and z, do these variables, when we run this function, do they give us, or should I say, when we run this function, do they give us a value which is exactly 0 in answer? If they are, assigned to rank the value of 9,999. Otherwise, what we're going to do is we're going to assign to rank the value of 1 divided by ans. And the reason we do that is because when we divide 1 by a small number, it gives us a big number. So for example, if I divide 1 by 0.5, we get 2. If I divide 1 by 0.05, we get 20. If I divide 1 by 0.0005, we get 2000. So pretty much the closer my solution is to 0, the higher the number here will be. So pretty much what we're doing is we're assigning rank a higher number based on how close these variables x, y, and z, when applied to this function, got to 0. So that is basically our fitness. We're checking how fit, how close to 0 this is. Okay, great. So if you understand that, perfect. Okay, so next up, what we have to do is we have to create our initial random solutions. And for this, we have to define a random number generator in C++, which is kind of annoying. So let's include. So here we have to define a random number generator. So make sure you include random. And pretty much what we're going to do is we're going to say std. So we're going to be defining our solutions in a range from negative 10,000 to positive 10,000. So what we have to do now is we have to include vector because we're going to be using a vector to store these solutions. Okay, so we're going to define a vector. And I'm going to contain in this vector a solution. And I'm going to call this vector solutions. So how many solutions do we want to generate as our initial solution set? So as our initial solution set, we want to generate, let's say, about 100,000 solutions. Okay, so I'm going to initialize this solution with 0 as its rank. Then I'm going to use the uniform distribution to just initialize my x, y, and z with random variables, or with the random values. So what I'm going to do is I'm going to initialize this solution with 0 for the rank. Then we're going to initialize the rest, so the x, y, and z components of the solution, with random values from this random number generator. Okay, just to recap, what we're doing here is we're pushing back into solutions. So this is a vector of solutions. And what we're doing is we're pushing back a new solution. We're initializing this solution with 0 as its ranking. Then we're going to assign, we're going to assign to the variables x, y, and z random numbers between negative 10,000 and positive 10,000. So x, y, and z, they will be essentially initialized with random values from negative 10,000 to positive 10,000, and rank will begin at 0. Okay, so we created our initial solutions. Now what we're going to do is we are going to just see the fitness of these solutions. And what we're going to do after that is we're going to sort them. So we're going to sort our solutions based on the fitness. Oh, and make sure you include algorithm. Okay, so what we have to do is we have to compare our solutions, and we compare our solutions like this. We're going to say left-hand side dot rank is greater than right-hand side dot rank. So what we're doing here is we're sorting our solutions. So we're saying arrange your solutions by rank. And because of that, we're passing in to this sort function this custom comparator. So we're checking if the solution on the left-hand side is greater than the solution on the right-hand side, that we're going to basically tell the sort algorithm, okay, arrange our solutions based on rank. So we're telling our algorithm to basically arrange our solutions based on this variable rank. And next, what we're going to do is we're going to print our solutions. So what I'm going to do is I'm going to print the top 10 solutions. Okay, so what we just did is we basically did a for each, and we went from the first solution, oops, I should this be begin. Okay, so we went from the first solution to the first solution plus 10. So basically, we want to take the first 10 solutions, and we want to print them out down here. So let's see how that worked. Okay, so we have a ranking of 0, ranking of 0. Okay. So we basically got, we didn't get really any good solutions. Let's try that with different parameters. Let me adjust this so it's between 100, negative 100 and 100. And let me just, instead of creating, so instead of creating 100,000 solutions, let's make 1,000,000 solutions. Let's actually make 9 million. Okay, so let's generate 9 million solutions and let's print them out and see what we get. Okay, so with the 9 million solutions, let's see what the best result was. Okay. So we got a solution with rank 3404, and this is the result down here. So let me just see if we got a proper solution with this. So as you can see, basically what we have here is we have the solution. The x is 11.8, y is 46, and z is 0.4. And if we apply this to our function, so our function is basically 6 times x, so we're doing 6 times 11.8, the negative y, so we're subtracting 46 from this, and then we're taking z to the power of 200. So basically we're doing the same thing. This is Python if you didn't know. We're going to click enter, and as you can see, we got 24.999. Now, this isn't a genetic algorithm, so if you just randomly generate solutions, that's just a random number generator. That's not a genetic algorithm. So what we're going to do is we're going to actually implement the genetic algorithm. This is just to make sure that what we're trying to do works. So maybe take down this a little bit. So maybe you want 1,000,000 solutions at a time, or you want 100,000 solutions. So what I just did is I generated 9 million solutions, and then I sorted them by this. Sort algorithm, just to make sure that what we're getting corresponds with reality. And then I printed the top 10 solutions here. Okay, so now that we did that, what we want to do is we want to take the top 1,000 solutions from our solution set. So this is part of the algorithm where we're just selecting the best candidates. So the best candidates in the solution set, we're going to take the top 1,000 of them, and then the rest of them we're just going to discard. So we're going to say, so I'm taking 1,000 solutions, I'm defining a variable called sample size, and we're going to define a new vector. And this vector is going to have, it's going to contain solutions, and it's going to be called sample. Then what we're going to do is we're going to copy the top 1,000 solutions from our solutions to our sample. So basically what we're doing here is we're taking the top 1,000 solutions and we're copying them from solutions to our sample. Then we're going to just clear out our solutions vector. Okay, so the next thing we want to do is we want to mutate our solutions. So what I'm doing here is I'm defining a new real distribution. I'm saying, okay, I want the numbers between 0.99 and 1.01. So basically, this is going to mutate our variables by at most 1%. If you want, you can make it 10%. So at most, we want to mutate by 10%. Or maybe if you want, you can have 20% like this. So it's really up to you. It really depends on how you want to mutate them, how much you want to mutate them. So for me, I'm just going to mutate them at most by 1%. So I'm going to just create a distribution like this. Okay, so what I'm going to do now is I'm going to do a for each like this. Okay, so what we just did is we mutated our solutions. And next, what we have to do is we have to do the crossover. So we have to recombine all of the top solutions into new solutions. So basically what we're going to do is we're going to take all of the old solutions and we're going to randomly recombine them into new solutions. And we're going to do it like this. So basically what we're doing here is we're taking the top solutions and we are recombining their components, so the x component, the y component, the z component, into new solutions into this solutions vector. And we're going to basically create, how big is this again? So this is going to be 100,000. So we're creating 100,000 solutions. So we're creating 100,000 solutions using the old sample. And this sample is, I believe, how many solutions is this? So we're taking 1,000 solutions and creating 100,000 solutions down here. So we're creating 100,000 solutions down here. So we're taking random elements from this sample and we're creating 100,000 solutions using those random elements in this new solution set. So that is basically crossover. We're basically crossing over. We're interchanging random bits from different solutions and we're creating new solutions based on the old good solutions. Yeah, I think that's pretty much it. So, and I believe we can just put this in a while loop and that should work pretty fine. Okay, so just to recap, what we're doing here is first we're creating our initial random solutions. So as you can see, we have random initial solutions. What we're doing is we're creating a new device. This is C++ specific, so don't really pay attention to this too much. So what we're doing is we're creating a vector of solutions, and then we're basically adding a whole bunch of solutions. And we're basically adding a whole bunch of solutions to this vector. Solution is defined up here. What solution is a struct. This struct has the variables rank, x, y, and z. So rank is just the fitness of the solution. So how good is the solution? So depending on how good the solution is, the rank will be higher. And we calculate the rank like this. We say if the answer is equal to 0, so depending on whether or not it's exactly equal to 0 down here, what we're doing is we're assigning it to 9,999. Otherwise, we're assigning it to 1 divided by the answer. And that just gives us how close we got to 0 based on this x, y, and z. And our goal here is to actually get to 0. So we're trying to find x, y, and z that give us 0 when we apply to this function. Okay, so going down here, our initial random solutions, I covered this already. So what we do on every iteration of this loop is we run our fitness function. So we check how fit our solutions. after we check how fit our solutions are, we're sorting our solutions by rank. We're passing into the sort function a lambda expression that's basically going to tell us, is the left-hand side greater than the right-hand side? And basically, all this does is just tells us to sort our solutions by rank. Down here, we're basically just printing our solutions. And then let's go down here. And then we're taking the top solutions. So in my example, what we're doing is we're going to take the top 1,000 solutions. So in this example, we're taking the top 1,000 solutions. So the way we're doing that is we're creating a new vector sample. And this sample vector is just we are going to insert basically everything from solutions.begin to solutions.begin plus sample size, and sample size is 1000. And don't forget to clear your solutions. Now what we're doing down here is we're mutating the top solutions by a percentage. So what we're doing is we're creating a new random distribution here. So we're basically just going through every solution and we're multiplying the x, y, and z by a random number here. Next up, we're doing the crossover. And what the crossover does is it basically recombines the old solutions and creates new solutions using those old solutions. So our sample is, don't forget, our sample is, how big is our sample? So yeah, don't forget, our sample is 1,000 elements, right? So what we're doing is we're creating 100,000 elements using those 1,000 elements. And what we're doing is we're taking random x, y, and z from this sample and creating a new solution. And because of that, we think that the best solution is some variant of this sample. So basically what we're doing is we're taking the x, y, and z, and we're creating a new solution based on that old solution. And that is the end of the loop, and then we just keep going back, and then we run our fitness function again, and we basically do the same thing over and over again. Okay, so let's run that and see how that works. On second thought, let's just compile this. So I'm going to do g++ and then ga.cpp. This is my file, ga.cpp. Let's compile that. And let's see what we get. So what we got here is the rank, and this rank is basically telling us how good is the solution, how close to 0 did we get. And as you can see, if I just close this and run this again, notice what we get at the beginning. So just close that. Okay, so as soon as I ran this, the first was 1. So the ranking of this first solution was 1. Then it went to 1, 1, then it started dipping a little bit. It got to 0, 0, 0, and then finally it started going up. So our rank on this generation was 700. Then it was 200, 200, 60, 50, and then it went all the way to 2000. And then right before I closed this program, it was getting up to 1,300. So basically, if I just run this and just let it run for a couple of seconds. So if we take the solution, let's copy this, and let's look at our function. Okay, so our function is 6 times x plus negative y plus z to the power of 200. So let's do that in Python. So we have to multiply the first component by 6. Then we have to take the negative of this one. So this is already a negative, so negative minus negative is a positive. Here is going to say this to the power of 200. Okay, and our solution, so basically from this, we got 24.99998. And there you go, that's a genetic algorithm. So yeah, that's pretty much how genetic algorithms work. They basically let you find solutions to problems you would otherwise have difficulty finding. That's pretty much it, and I will see you later.